Looking at the 8.3 guided practice problem, solving exponential and solving logarithmic equations. With exponentials, our main goal is to get the same smaller bases. From what I've seen on the homework so far, most of us are pretty good when the bases are non-fractional. So, for example, if I look at these two bases, I know that this is an exponential equation because the variable is up in the exponent. This one is 25. This one is 125. So either using our knowledge about perfect squares and perfect cubes, or we can look at our sheet. We see that I can write both of those as base 5. So I'm going to replace 25 with 5 squared, and I'm going to replace 125 with 5 cubed, and then I've still got the x plus 4 and the x plus 2. The biggest little mistake that I see on this section is sometimes students will forget to distribute that exponent to both of those powers, so pew, 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 pew. So making sure you distribute to both of those, and then once you simplify that expression, we would get 5 to the 2x plus 8 equals 5 to the 3x plus 6. And at this point, once we have the same bases, we can cross them off and drop those exponential expressions to ground level. So then 2x plus 8 equals 3x plus 6. Subtract the 2x and we get x. Subtract the 6 and we get 2. Sometimes students look at this and they go, ooh, are there extraneous solutions on this? The answer is no. I can have negatives up in the exponent. I can have 0 up in the exponent. I can have fractions. I can have radicals. Everything goes when we're solving exponentials. So if I wanted to just check myself, not check for extraneous solutions, but just check myself, I could on my calculator try 25 to the 2 plus 4 and 125 to the 2 plus 2. And you'll see that we get the exact same answer. So if you want to check yourself for accuracy, you can on these using your calculator, but you don't have to check for extraneous solutions like you do with the logs. So exponentials, same smaller bases. Now, the ones that I've been getting emails and questions about is like number 2, because I've got an exponential equation since the variables are up in the exponent. But as I look at these bases, I have base 3 and 1 over 27. So base 3, I can't do anything with it. I can't make it any smaller of a base than just 3. But can we write 1 over 27 as a smaller base, in particular as base 3? We can. So the trick is, because this is what I've been seeing confusion on, is whether we replace this with 3 to the negative third, or like 1 over 3 to the negative third, or 1 over 3 to the third. Well, first of all, not all of these are equal to 1 over 27. Negative third, let's get that on screen. 3 to the negative third, gross little decimal, is 1/27th. But 1 over 3 to the negative third, that's regular 27. I can't put this in for that because it's not equal to 1 over 27. This one, 1 over 3 to the third, that one is good as well. So folks, both of these are equal to 1 over 27. Which one do we want to use? The one where the base is exactly the same as the one over here, which means we don't want any more fractional stuff. We just straight up want 3 at ground level. So I am going to replace 1 over 27 with 3 to the negative third. So I'm not like doing an operation. I'm not adding 3 to both sides. I'm not cubing both sides. We're just replacing the base with something it is equal to. Now from here, we've got 3 to the 2x plus 4. And then we distribute to both of those terms. So then negative 3x minus 6. Drop off the bases once they're the same. Goodbye, goodbye. So then 2x plus 4 equals negative 3x minus 6. We add the 3x to give us 5x. We subtract the 4 to give us negative 10. Oh, and this one worked out nicely too. I was expecting a fraction one. So we end up getting x equals -2. Now, if you want to check yourself for accuracy, you can on your calculators. And folks, just make sure if you're using an older calculator, after you do the caret symbol, you will have to trap the exponent in parentheses. So if you have a graphing calculator, the parentheses aren't necessary, but an older calculator, you will want to have those. So, we get 1 when we plug it into the left side. And if we plug it into the right side, I see why we end up getting 0 up there. So -2 plus 2, anything to the 0 power is 1. So it's not a bad idea to check your answers, especially because, is this you guys' last unit test? No. Unit 9 is going to be your last unit test, but we're getting very close to the end of the term. So if you would like to finish strong and get all the points, it's always a good idea to check yourself to make sure you're not making any little mistakes on those. So folks, then we arrive at number 3. Can I rewrite 4 as a smaller base? We could. We could write it as 2 squared. But can I write 12 as a smaller base? Wah, wah. We can. We can write it as 3 times 4, but I can't write it as something raised to a power. As you'll see, 12 squared is 144, but I can't break 12 down into a smaller base. So, folks, what do we do when we cannot get them to be the same base? We log both sides. So this is that weird case where if you can't get the same bases, you use logging as an operation. So log both sides. And when we log both sides, we're going to use common log unless you've got base e, and then you natural log both sides. So I'm going to write log in front of this base raised to that exponent, and then log in front of this base. My orange pen is running out. All right, there we go. And you go, oh, great, now it's just more complicated. We got the word log there. What logging both sides allows me to do is to change this exponential equation into a ground level equation. Last week when we were talking about expanding and condensing, we said that when we have a log out in front, we can take that exponent and move it out in front as a coefficient. Folks, you can only do that if you have the word log written there. You can't just pull exponents out of the sky for no reason. But if I have a log in front of it, because of what's going on in the background with the exponential form, you can move that 3x out in front. So then I have 3x common log 4 equals common log 12. From here, if we want to try to isolate our x, this is 3 times x times log base, or log of 4, common log of 4. So I can divide by, actually, let's just divide by log 4 first. We'll divide by log 4. That's going to give me something gross probably. And then I'm going to divide by 3. So I'm going to do common log 12, making sure I close off my parentheses, divided by common log 4. So I'm just using the regular old log button on my calculator, defaulting to log base 10. So log 12 divided by log 4 is that yucky thing. And then if I divide that by 3, that gives me, to 3 decimal places, 0.597. Yuck. We can also check for accuracy here. So if I do 4 to the 3 times and I use the straight up answer that I got there, wow, it tells me that I get exactly 12. If I use my rounded answer, we see that, yep, we get pretty darn close to 12. So if you use the non-rounded answer from your calculator, that is a great way of checking yourself as well. Folks, any questions on the solving exponentials? And again, how do I know I'm working with an exponential equation? Because your variable x is going to be up in that exponent position. So exponential equation, we want to get the same smaller bases, being wary of any fraction problems. And if we can't get the same bases, we log both sides. Moving on to our log problems. Log problems are the ones where we have to check for extraneous solutions because the answer part of the log has to be greater than 0. So you can have negative solutions, like I can have x equals -2. It's all about what it does when we plug it back into the answer part of the log. Now, how I remember how to solve these is if I have one log, and this goes for evaluating logs as well, I put in exponential form. If I have 2 or more logs, we will either condense or cancel. So that's kind of my plan of attack with these problems, is just determining how many logs do I have and what am I going to do with those logs. So if I look at number 4, we see that we have one log. So I can't just cross off that log like I'm the god of math, even though I might want to do that. Instead, when we see the word log, we think of that elephant with his big animal ears. You guys remember me yelling that at you last week? So big animal ears, where 4 is the base, A is the answer, and then the ears is the exponent that goes with the base. And look at what that's done for us. No more log, and now I just have this nice ground level equation where I want to try to isolate x. So I get 16 equals 5x plus 1. Subtract the 1 and we get 15 equals 5x. Divide by 5. And x equals 3. Now, before we put a box around it, we have to check for extraneous solutions. So I need to make sure that this guy doesn't make the answer part of my log less than or equal to 0. The answer part has to be greater than 0. So if I plug in 3, I get 5 times 3 is 15, plus 1 is 16. So is 16 greater than 0? Yup. So it's not about 3 being greater than 0. It's about what the 3 does in the answer part of the log. So x equals 3, woo! That's our solution. You don't have to show this check, but anytime you have a log in the problem, you got to make sure that you do it. Questions on that one? Question? On how we checked it, so I took the 3 and I plugged it in for this x. So 5 times 3 is 15. 15 plus 1 is 16. So the answer part of the log is what's inside the log, and that's what has to be greater than 0. So because when we plug in that 3, we get 16 inside the log, the x equals 3 is our solution. Okay, more questions? And we're going to see another example with the next one. Looking at number 5, we have 2 logs. So if I try to put this in exponential form, it's like, that's my big, that's my animal, and then, oh my gosh, there's another log over here. So this one's a little bit different because I have 2 logs. It's sort of like what we did up here with getting the same bases and being able to cross them off. If I have the same log on both sides, we can just get rid of them and cross them off. It's lovely. Couldn't do that on this problem because there was only 1 log. But because I have 1 log on either side without any coefficients, I can just go ahead and cross those off. So then I get x squared minus 2x equals x plus 10. And hopefully, folks, since this has been kind of the vibe of term 2, when you see an x squared, your knee-jerk reaction should be, I'm going to try to factor that. So, yeah, I guess you can use the quadratic formula, but factoring is way easier. So let's try to factor it. And before we factor, we need to move everybody over to one side. So we're going to leave that x squared there. We're going to subtract x. Subtract the 10. Equals 0. So we're looking for a product of negative 10 and a sum of negative 3. So x minus 5 and x plus 2. Negative 5 and 2 give me a product of negative 10, and then negative 5 and 2 give me a sum of negative 3. So then we said each of those equal to 0, either x minus 5 is 0, or x plus 2 is equal to 0. X equals 5. X equals negative 2. But wait, there's more. We have to check both of these in both of these log answer parts to make sure that they don't give me something that's not greater than 0. So folks, on this problem, I have 2 log answer parts that we're going to need to plug those 2 possible solutions into. So I've got this log's answer part, the stuff inside the parenthesis. That crap needs to be greater than 0. And then we got this stuff, which also needs to be greater than 0. So folks, I'm going to start with plugging in 5. So 5 squared is 25. Minus 2 times 5 is 10. 25 minus 10 is 15. So folks, is 15 greater than 0? Yup. So it works in that log's answer part, but then I have to check it in the other one as well. We plug in 5 and we get 15 as well. They don't necessarily have to be the same, just a mental note as we start getting into ones with like more than one log. So is 15 greater than 0 over yeah? Yes. So that means because both answer parts are greater than 0, that 5 really is our solution. So now we take a look at the negative 2. Negative 2 plugged into this log's answer part, starting to get a little messy here with my arrows. Negative 2 squared is 4. Negative 2 times negative 2 is 4. 4 and 4 is 8. Is 8 greater than 0? Yep. And if I plug negative 2 into this log's answer part, we get 8. And 8 is also greater than 0. So, cool. Sometimes both solutions will work. Sometimes only one of them will work. Sometimes none of them will work. What do you write if none of them work? No solution. So it all depends on what they do in the answer part of the log. Notice that this 2 is negative. Some students are like, well, it's a negative 2, so isn't that like a problem up here? I can get negative solutions. They just have to make my answer parts of the log greater than 0. It's probably one of the most common misconceptions with the log stuff, and it will follow you guys for those of you going on to take pre-calc as well. All right, folks, so that one, way different. How we went about solving it was we identified how many logs we had. There were 2, and since I had them in equal spaces on both sides, we can cross them off just like I did with having the same basis on that one. Anytime you see a quadratic, get it equal to 0 and try to factor it, and then don't forget to check for extraneous solutions. And again, that is only for the log equations. So taking a look at number 6. Now this one, we have 2 logs. Why can't we just cross them off? They don't equal each other. So it's not balanced. I've got 2 logs over here, and then I've just got this awkward 2 just hanging out. So sometimes students will try to move this log over here, and they'll be like, oh, now I can cancel out those logs. But because I have 1 log, and then 1 log, and then the 2, we can't actually cross those off as equal parts. So this one, we have to use a different strategy, namely condensing. So folks, how do I condense 2 logs that are separated by addition? What operation do I use to condense those? Multiplication. So x squared minus 9x equals 2. I have just made the biggest mistake that I see on the solving part of the test. Does anybody see what it is? What am I missing? The log. And if you're like, do we really need that log? We actually do, because if you try to move that 2 over and you try to factor that, product of negative 2, sum of negative 9, yeah, that's not happening. We are not going to give you any problems that require the quadratic formula. Now, if you suck at factoring, yeah, maybe you'll have to use it, but if you get something that is unfactorable, that should be your red flag to back it up and see if you maybe missed something. So we have to have the log written here. So I'm going to put an important box around that. Because why is this log so important? It dictates what our next step is. How do we now solve a one log equation? We put it in exponential form. So we see the word log, we think of that elephant with his big animal ears. And we get 6 squared equals x squared minus 9x. Now, is this a quadratic we're going to be able to factor? I think so. We're going to move that 6 squared, or that 36, over to the other side. Minus 36. Oh, and let's see. 12 and 3, I think, are going to be our numbers. So x minus 12, x plus 3. So then I'm running out of room, so I'm going to skip a little bit. We set each of those factors equal to 0, and we get 12 and negative 3. If you don't have that log there, you're going to get something that you can't factor, and you're going to get very stuck. So when you condense, make sure that you're writing the log in front. And that goes for the condensing part of the test as well. Don't just do the operations with the answer parts. Make sure you have the log written out in front as well. Now from here, we have to check both of these solutions in the answer part of our log. So I'm going to start with the 12. Is 12 greater than 0? Yup. 12 minus 9 is 3. Is 3 greater than 0? Also yup. So x equals 12, legit a solution. If you're like, what about that 2 over there? It's not inside a log. It's not the log's answer part, so we don't have to worry about plugging anything in over there. Now for the negative 3. Is negative 3 greater than 0? No! Doesn't matter what it does in the other answer part of the log. You will see that it gives us negative 12, which is also not greater than 0. So that would be an extraneous solution. You don't have to write extraneous. You can just cross it off, as I have done here. Have to show me that you found it, that when you plugged it in, it did not work. So folks, that is solving in a nutshell. So as you can see, every problem is a little bit different. So if you're someone who just kind of likes to only do the odds on the review or skip around, make sure you do every single problem. Every problem has its own nuances, and that's how you're going to start picking up on those strategies there. Any questions on any of those problems? Any questions on the review so far that you would like me to walk through? Yes. Number 20. All right, review time. All right, number 20. All right, so expanding and condensing. Expanding, we want to get as many possible logs as possible. Remember, expand everything on the land. And then condense, we want to send our coefficients to the clouds and get a single log. So folks, number 20, I am starting with a single log. So it's already as condensed as it will go. So we want to try to expand this one. So folks, we begin by identifying what is going on operation-wise in the answer part of the log. Since the answer parts are getting multiplied together, we are going to expand it by addition. So log base 3 of A plus log base 3 of B to the 4th. Sometimes students will just start there, which is why I've got my little phrase, expand everything on the land, because we also need to move any exponents to the land or out in front as coefficients. Right now that exponent is floating up in the clouds. We want to bring it to the land or ground level. So log base 3 of A plus 4 log base 3 of B. So operation between the answer parts and then handle the exponents. Now, the flip side of that is a problem like 22. These ones are separated by subtraction, but why can't I condense these right away? The coefficient. You cannot condense logs that have coefficients. So if I want to condense this into a single log expression, we first have to send that 2 to the clouds. So I'm going to back it up as a power of the n. So log base 5 of m minus log base 5 of n squared. Now that I don't have any coefficients, these two logs are separated by subtraction. So what operation do we use to condense them? Division. So the m is going to go on the top. The n squared is going to go on the bottom. And if it makes you feel better, you can trap that in parentheses, but you don't have to as long as it's clear that these are inside the log and your base is 5. More questions on the review. All right, that concludes the 8.3 guided practice video.